Hello. Today we're talking about the empirical rule in histograms. So we'll be able to find probabilities and percentages of a normal distribution using the empirical rule. So this may look familiar. You did learn it in FST, but I don't believe it was actually called the empirical rule. We just used it. So what it says is that when you have data, and so this mu here, this is our mean. And then this is standard deviation. And essentially what this empirical rule states is that 99.7, let's start with 68. So 68% of data is within one standard deviation of the mean. Meaning if you add standard deviation, subtract one standard deviation, 68% is within there. So that kind of takes into account rounding. So technically we'll look at this as 34.1%. and 34.1%. And yes, that equals 68.2%, but the rule doesn't look quite as nice if we do that. So it also says that 95% of data is within two standard deviations. So what that means is that from here to here will be about 95%. So we're going to call this 13.6%. I'm going to drop the percent. It is a percent, but we don't need to write it. And 13.6%. And keep in mind, if you add 13.6 plus 13.6 plus the two 34.1s, you get 95.4. Again, rounding, okay? About 95%. And then 99% of the data are within three standard deviations. So 1, 2, 3 to the left, 1, 2, 3 to the right of the mean. So that should equal 99.7. So this in here is 2.1%. 2.1%, and then outside or left with 0.2, so greater than 3 away on either side. So keep in mind the general, so 68% of data is within one standard deviation, 95% within two, 99.7 within three. But these percentages, again, some statisticians came up with them, so we just use them. I would say memorize them, but since tests are open note, just be able to use them. I'll show you some examples. So we have the systolic blood pressure of adults are normally distributed. The data are. Data is, data are. It's always weird, plural or not, you know, the grammar seems strange. Normally distributed with a mean of 128.4 and a standard deviation of 19.6. So we need to make a normal distribution. So to do that, just kind of make a curve that looks kind of like a normal distribution. Make a line here. Draw a line in the middle. That's going to be our mean, okay? And then we'll go 1, 2, 3 away, and 1, 2, 3 away in the other direction. So our mean in the middle, we actually know what it is. It's 128.4. And I'm going to write sideways because otherwise we're going to run out of space here and it's going to get all crunched together. So if the mean is 128.4, standard deviation is 19.6. Well, if you add 19.6, you get 148. If you add 19.6 again, you get 167.6. If you add it one more time, you get 187.2. And if you take 128.4 and you subtract 19.6, you get 108.8. Subtract again, you get 89.2. One more time, you get 69.6. So what we know is that 68% of the data ends up falling within one standard deviation of the mean, because that's just kind of the definition. So our mean is right here, so 1 up and down is right in here. Okay, so that's going to be our 68%. So that interval is from 108.8 to 148. And then we'll look for the interval where 95% falls. 95% falls 2 standard deviations. So if you go 2 over, we're here. 2 over, again, we're starting with the mean. 2 to the right is here. So that's 95%. About, again, with those particular percentages, it was 95.4, but it's approximately 95%. So that goes from 89.2, because there's our value here, to 167.6. And then we're looking for 99.7. So 99.7, that'll be 3. So we start at the mean and count 1, 2, 3. So we're right there. Start at the mean and go 3 to the left. 1, 2, 3. So here's our range in there. That's 99.7% of the data approximately. And so that goes from 69.6 to 187.2. The heights of a certain population of males are normally distributed with a mean of 69 inches and a standard deviation of 6.5. We're going to approximate the proportion or percentage of population whose height's less than 82 inches. So we'll draw a normal curve, kinda. As long as it's symmetric, it works okay. So there's our mean, and we'll go 1, 2, 3 to the right, 1, 2, 3 to the left. Our mean was 69. You add 6.5, you get 75.5. You add if you add 6.5 again, you get 82. Add it one more time, you get 88.5. You start with 69 and subtract 6.5, you get 62.5. You subtract again, you get 56. One more time, 49.5. So as far as our percentages, let's fill them in, okay? So this is really just coming from the first page, because this is something we just memorize or just use. So these right here, within 1, these are both 34.1. These are 13.6 on either side of that. And then we have 2.1 and 0.2, 2.1 and 0.2. So we're asked to approximate the proportion, we'll just go percentage, of the population whose height is less than 82 inches. So less than 82 inches is everything to the left of right here. So it's 0.2 plus 2.1 plus 13.6 plus 34.1 plus another 34.1 plus 13.6, which is 97.7%. If you're thinking, is there a quicker way? There is. You could actually just take 100% and subtract out 2.1 and 0.2. And that will also get you 97.7%. Okay, the Stanford revision of the Binet-Simon scale of intelligence, IQ. Normally distributed with a mean of 100 and a standard deviation of 15. To make our little picture. I know my normal curves are great. It's the mean, and we'll go 1, 2, 3 away. 1, 2, 3 away. So our mean is 100. Add 15, we get 115. Add it again, 130, then 145. Subtract 15, we get 85. Do it again, we get 70. Subtract 15 one more time, we get 55. So we're looking for percentages in these questions. So I'm going to fill in the percentages from the first page. So again, this was 0.2, 2.1, 13.6, 34.1 and 34.1, 13.6, 2.1, and 0.2. And so what percentage of adults have an IQ score between 100 and 130? Well, 100 to 130, that's basically from here to here. So we have 34.1 plus 13.6 which is 47.7%. What percentage of adults have an IQ score above 145? Well, to the right of 145, that's just 0.2%. So not very many is the point. I've always wondered what my IQ is, but I have no idea. And maybe I don't want to know. I don't know. What percentage of adults have an IQ score between 70 and 85? That's here to here. That's just 13.6%. Pause the video and try to do this one on your own, and then come back. Okay, so I'm assuming you tried it. Now we're back. The resting breathing rate for college-age students is normal with a mean of 12 and a standard deviation of 2.3 breaths per minute. So let's make our normal curve, or some approximation of it. My pictures are terrible. Here's our mean, and we'll go 1, 2, 3 to the right, 1, 2, 3 to the left. Our mean was 12. 12 plus 2.3 is 14.3. Added again, we get 16.6, and then 18.9. You know what? I'm going to redraw this so it's bigger, so that it doesn't get so messy. Sorry about that. At least wider, so I have more room to write my numbers. Okay. Mean, 1, 2, 3, 1, 2, 3. Okay. So we had 12 plus 2.3 is 14.3, and then 16.6, 18.9. If we subtract 2.3 from 12, we get 9.7, and then do it again, we get 7.4, and then 5.1. I'm going to fill in our percentages. Okay, again, these are just taken from the front. You memorize them / use them since you don't have to memorize anything these days. 0.6 on either side, 2.1, 0.2, 2.1, 0.2. Okay, what percent of all students would have breathing rates in the following interval? 9.7 to 14.3. 9.7 is here, 14.3 is here. So 34.1 plus 34.1, which is 68.2%. What percent of all students would have breathing rates from 7.4 to 16.6 breaths per minute? 7.4 is here, and then we go to 16.6, which is here. So we have 13.6, two 34.1s, and a 13.6. And that is 95.4%. And again, that's that how much falls within 2 standard deviations of the mean. Lastly, what percent of all students would have breathing rates of more than 18.9 breaths per minute or less than 5.1 breaths per minute? Well, more than 18.9 is 0.2%. Less than 5.1 is also 0.2%. So both equal 0.2%.